leads to like why this situation come, like deployments will crash in production. If it is like QA environment or like any lower environment, you don't really care. It's needed, it will impact timeline, but like you don't really care. But if it happens in the production, you need to keep everything aside and look back what is happening and how to fix it. And similar stuff, many developers kind of related to it. How many of you are developers here? Right. So every time when you write a test case, that with so much confidence that hey, I wrote this functionality, and for this functionality I wrote specific test case. My assumption is that if it is working here, it should work seamlessly in my pipeline as well. But you're not building pipeline most of the times, and your pipeline which is running your test script or the unit test, whatever you call it, the integration test, any sort of testing which is working in your machine might not work in a pipeline, right? So how do you come across that? And then finally, frustrated teams, and then blame game that hey, I'm a developer, I wrote code, my code has everything is working fine. The DevOps engineer don't know how to configure the pipeline, so that is why it is breaking. And then DevOps engineers or like SREs, whoever you call it, they say, hey, infrastructure wise everything is good. The developer didn't write code in a standard conventions. So that's where it is breaking. So this sort of blame games will come, and essentially what it tells us is like you need to have a rock solid pipelines. How do you build it? Is the story. Okay, what are we going to cover today? Like I mentioned, we are not mastering anything, we are not doing any magics here. It's just a simple 4 topics. One, test containers, Docker, Jenkins, Kubernetes. As simple as that. So we try to understand what this is for, and like how do you use in your production grade systems, right? That's the simple agenda. So with that, who am I standing here and telling that? Like I'm Koti Vellanki, and I'm working as a senior DevOps engineer at a company called TransUnion. We are into fintech, and this is my LinkedIn profile, and then GitHub, and like my email ID. Okay. Now to follow this workshop, we already communicated. Hope you got this communication. So we need 4 things. One is a GitHub account, like if you wanted to fork the repo or like just clone it and make your own customized way of things, you need a GitHub account to store the code. And then minimum PyCon 3.10 plus will be good, because I tested and all these scenarios which I'm gonna demo now are built with this. And then test container desktop for a very small time, initial 15 minutes or so, because like that is using that, like you can really see what is happening when you write a test case and then when you run it. And then finally, most important one is Docker desktop, because a lot of times when you want to provision a cluster and then like in any form, it's kind of chaotic. But if you have a Docker desktop, you can run everything related to Docker also here, Jenkins also from Docker images, and then Kubernetes also, you can spin up a Kubernetes cluster also from the Docker desktop itself. So I'm assuming like these are the things, and then this is a QR code for the GitHub repo. And like before, we just wanted to reiterate on what are the problems we mentioned, right? It's just like why we need really reliable pipelines is like you need speed, because you don't want it to run one pipeline and keep it days and days together. Like when you run, it should work seamlessly, and it should be quicker. And then you need to have a security in mind, because like you just pull up an image and which is having n number of vulnerabilities, and your pipelines or everything started failing because of some security scanners. That is not something you're looking for. So everything has to be, speed, safe, and then reliable. So with that, we'll jump into test containers, which is like first topic, first of the four which we're gonna see. So test containers, in short way, it's a like Python library, similar to any other libraries which we have. Test container is also a simple library, but what it will give us is a capability to run your real-time environment-related scenarios. What I mean? Now, you have a, we'll see it as an action as well, but like just, so you're running an application with specific version, like your database, for example, MySQL, running on 8.x, or but you, in your local, you have 7.x. But what you wanted to test is like whatever your production gonna have, the similar thing you wanted to test. So if you wanted to do it in a manual way, you need to have two environments within your system, like one is with MySQL 7.x or 5.x, and then with 8.x. Similarly, Postgres, if we take an example, Postgres 13, 14, 15, like there are many versions. So you wanted to run specific functionality on a specific version, you need to set up everything in your local, which is kind of chaotic. And then most probably it tends to lead lot of environmental issues, and you never know like why something is breaking, like everything working before like might not work when you're actually into the stuff. So that is the reason test containers came into picture. Using test containers, these are like short-lived environments, or in other words we call it ephemeral environments, right? So once you have a test case study, you written a test case, it will spin up whatever you need. Like, okay, I need Postgres 15.x some version, and with that I wanted to test a create functionality. I want to create a table, I want to delete a table, I want to insert some records into the table. All these kind of things I can define in my test case, and it will provision exactly the same and test your test case and then show you the results. And once the result, once the execution is completed, it will remove whatever the resources it provisioned. It's as simple as that. So that is the reason, like I'm just trying to introduce test containers. So it's kind of another theory. We'll just jump into the hands-on. So I already shared the URL, and like, so this is the URL. So you can just go here. So copy. So I just created one empty directory and nothing actually inside this. Okay. So what I'm trying to do is I'm trying to clone that repository to my local. Okay. Now I have this CI/CD chaos workshop, like I mentioned. So we are not just going in a traditional way of like, okay, I have worked on build some of the pipelines, and like when I just with one run it will run. That's not what we are gonna see today. So what we are gonna see is we create some chaos, we intend to run some failures, and then we understand the failures, and then we run the actual solution. So this is the approach that throughout the next one and a half hour, like we're gonna see. So with that, just clone the repo. How many of you are ready with cloning the repo? Okay. I'll just give it a minute. Please get that in cloned, and then we'll start running. Yeah, we have volunteers all across the room. Like if anybody having any difficulties in setting up, like please let them know, so we can all proceed further. Shall we start? Yes? No? Okay. I see a couple of faces in the back. So, okay, cool. So I'm assuming like we have cloned the repo, and then I'm just entering into that repository CI/CD chaos workshop. Okay, and then if I see like I have these whatever we talked about, like four different directories we have: Docker, Jenkins, Kubernetes, and test containers. Right now we'll get started with test containers. I mean inside the test containers. Okay, if you just see, I'm inside the test containers, right? So it has I crafted three kinds of labs. Labs are like nothing but regular scenarios. So in three levels, like basic, intermediate, and advanced level, only for the test containers. So what I'll do, I'll just go to labs, a basic one. So how many of you have test container desktop installed? Okay, it's good to have. If you don't have, like maybe you can monitor my screen like when you run also, so it will show what I mean. Okay, now here like I have bunch of scenarios like basics one, connection, and like those things. So in every scenario I'll try to run one or two examples, keeping the time as in mind, and then you can feel free to explore all the other scenarios, right? So I just run the first one, which is a simple one. What I'm trying to do here is okay. Before that, I'll just try to open the code. Okay. This is the workshop directory. Okay. So if you see in the test containers, so I have these labs. Okay, in that like I have categories and then basic one, and then so everything has, like I mentioned, there is one chaos and then one working one. So first we'll try to run the chaotic one and then understand what is the issue, and then we'll try to fix this. So like everything you see in the scripts, everything is written in Python, and like the system versions, everything we have defined. So without any further delay, I'll just try to run this. Okay. So I'm in this basic directory, and then if I just see, like I'm seeing the same whatever I'm seeing here, like I'm the same thing. So I'm using Mac, so that's the reason I'm passing command as Python 3. If you are into Windows, you don't need to specify 3, right? And yeah, okay. One more thing I forgot, like before that, like so it has some dependencies and all the Python related stuff it need to install. So for that, okay, I'll go back. Yeah, here, like if you see, I have a requirement.txt. So I'll do one thing. I'll just create one virtual environment, and then I'll try to run this thing here. Okay. So I'm just running this command. What I'm trying to do is like I'm creating a virtual environment with the name Testcontainers. Okay, Testcontainers got created, and then I'll activate this environment. Okay, now I have the Testcontainers virtual environment activated. I'll just run this command pip3 install requirement.txt. So what it has is, it has all the dependencies to run the test containers and other dependencies. So first thing is the test containers, and then I'm trying to show like Postgres, MySQL, and Redis, all those databases. So the databases related stuff we have, and then Docker, and then I also have a Flask and the stuff, right? So these are the things I have. I'm just trying to install all those things, all the dependencies. Okay, all the dependencies got installed. Now I'll just go to labs and then I'll run the first lab. So this is Postgres K8s, right? So which is intended to have failures. So what is this doing? Like you can also see here. So in the test container tester, like you see the containers. Okay, it ran and it has some issues that okay. So some of the scenarios, like if it has it is trying to enter these records, okay, into the Postgres DB. This is the test case which I have written. And then in that, if there any negative amount or if there any duplicate email, so it is not handling, it is just directly rejecting, right? So now what I'll do, I'll just run the other one, PostgreSQL one, and like as soon as you run this, you can see the test container here in the from the test container desktop. So it is trying to provision that particular container, whatever the database you will specify, and as soon as the test case execution is completed, it will get terminated. I'll just one more time, please be attentive. Like as soon as you run, whatever the test case you have, so it will spin up that, and you can see this container spinning up, and then it will terminate. Clear? So it is not just assuming things like okay, now I'm working or like developing something with one version, and in production also the same thing version might be there. So it is not doing that. So you are mentioning that hey, whatever I am writing, that particular test case, it should work in all the versions. So that's what you're testing here, without actually impacting your local or any development environment. Right? Clear? Any questions? We'll see one more example, and maybe it will be more clear. So that is one, and then we have like multiple containers one. I'll try to run this. Okay. So when you have multiple containers, the issue is that containers might not talk to each other, right? And so I'm just trying to run, and then please pay focus on here. Okay. So containers are spinning up, and as soon as it is running, and it is getting terminated, and it has like lot of issues here. So the rollback is not happening, and Redis is not coming up. So it tried to send so many records, and then it kind of failed. Right? But the same thing, what I'll do is like I'll try to fix the command. If I just run this, so now, so for Postgres is came up, Postgres various versions it is coming up, and then Redis also came up, and it is checking and waiting, and if you see Redis health status and everything is green. So initially Postgres and Redis couldn't talk to each other, and then now when we fix that connection issue, and it is started working. Right? Similarly, like we have various other scenarios as well. Like you can feel free to jump onto it and then explore by your own. right? There are like 8 to 10 scenarios. Got an idea about test containers? Any doubts? You getting it, or is it like too much? It's too fast, too slow? Anything that you wanted to share?
May I know what's the difference between the K8s and also the normal one?
So K8s has some intentional values. For example, if you see the lab for which we ran, multi-container one. So I have two containers. One is Postgres and Redis. So I kept in my test case in a way that Postgres couldn't talk to Redis. So if imagine the same thing happened in your pipeline. So both are in different network and both are not talking to each other. So that time your communication or the application won't work. So that's where we fixed it on the second one. So that's about test containers. Now it brings to a different thing that, hey, now we are talking about test containers, but we know test, but what is containers? Like test is something everybody came across, right? So we, like being a developer, like you write test cases and you see like a lot of testing is happening for every functionality and all. That is fine. But what is container? So container is nothing but whenever you build an application, or like we have a code, developers wrote the code, and then you need to deploy it to somewhere into one server which is sitting in some place. How do you do it, right? Like, so you traditionally we try to copy it, like using WinSCP or like some SCP commands, like from your local to you copy to remote server, and then whatever the commands you are using to run this, you run the same thing there, and then it should work. But we tend to have a lot of environmental issues that we also come up with this fancy thing that, hey, it works on my machine, but it might not work in your machine, right? That is happening because, so it has the local dependency. Just before this, like we saw the virtual environments, we created virtual environments and we ran this requirement.txt to make it work, right? Imagine if you are not using that and if you are installing all the packages within the machine, right? And next time when you wanted to try something different, it won't work as it is. Right? So how? Because they are sharing the same underlying architecture and everything is talking to each other, that leads to a lot of confusion. So that's where when you have an application and you want to ensure that like once it runs here, it should run everywhere, you need to package it, just like how you order from an e-commerce or like online store, right? So for example, you wanted to buy a phone, something like this, and you wanted to order from the online store. So what essentially happen is, when you order, they won't just give you phone just like this, just open it and give it, right? Like what they do, they package it in a nice box, and then they seal it, and then they'll ship to your location, and then you open it carefully. Just exactly the same thing, and developers are building some application and they're writing a lot of code. If you just give the same code without packaging and directly giving, there is a chance that like it might have get into the issues which we talked about, like platform issues. It is working here, might not working there and all. But if you package it well, you don't get into these kind of issues. So containerization is nothing but that, and once you have any application running using this containerization technology, we'll call it as container. Simply, it's like simple running form of your application, right? Or the package, your e-commerce package which you got. No, so that is what I said. Like, so it works. Yeah.
Sometimes I saw some GitHub reports they covering with dev containers. So I would like to know a little bit more on how is the dev container is different to the test
Yes. So yeah, that's a good question. So there are like two different things. Like his question is just to repeat. Like see, so we are hearing about Dev containers and what is Dev containers and what is the difference between Dev containers and test containers. Dev containers is nothing but a ready-made environment that you provision. So what you do is now you wanted to run a workshop. So this workshop you're running in your laptop, right? And imagine you don't have laptop or like you're restricted to have installations in your laptop and you want to have one server or like one virtual laptop where you wanted to install everything. That's where dev containers come into picture. So it's essentially a virtual machine where you set up everything like with a simple commands like so just add and then package, right? Like so you have like blank server with you and then you keep your code there, you keep like what are the softwares to run that code, everything you install it there. It's like a mini laptop which is sitting on some place and you accessing through GitHub code spaces and all, right? Like some sort of dev container. But test container is not that capable, and there is no comparison in first aid. Test container is something like now you are working for an application, kind of Facebook. So in a Facebook application, you are writing a test case for login. In any time a user wanted to log into Facebook, they need to provide the username and password, or email, mobile number, what are the password combination. This particular functionality you need to test it. How you test it? You write the code is there, and then in that code you pass some certain parameters that hey, every time like when somebody entered username and password, validate that the user is exists or not in the database. If the user is in the database, user has the same password which he is entering. So these are the some basic scenarios, right? You wanted to test these scenarios in the production machine, which is technically difficult because production systems are for the production. You can't do the testing in production. But what will happen when you wanted to do a sudden upgrade? There is some security issue or there's some CV rising, right? CV, everybody aware of CVEs, right? Like security owner. So some suddenly they say like okay, in Postgres 15 there is a new CVE, you need to upgrade it. We have to upgrade, there is no other choice. But if you upgrade it, your test code or the code which is written here will work or not. That is the question. So we are not 100% sure. To simulate before going to production, if I wanted to simulate that, hey, in Postgres 15, my test case will work or not, that's where test containers come into picture. It will give you that environment in your local and test the functionality and then spin up and then go on. And yeah, so dev containers, like I mentioned, it's a complete new server and where you install things, run things, and keep it as your own server. Right? Yeah. Thanks for that question. So now, so that is about like containers, containerization and stuff, right? So now, how many of you used containers Docker before? 1, 2, 3. How confident you or like in Docker, like out of 5? I'm not asking any questions. Yeah, usually like if I take my example, my experience with Docker, like I just started learning Docker some time back, and then I gone through some other tutorials, and then when I ran check these things, right? Okay, I'll just try to run a simple thing. So in the Docker, so test container is clear, right? Like we are moving it to Docker. So in Docker, we have like 5 scenarios. We try to run at least 1-2 scenarios. Okay. Now nothing much. Imagine I'm assuming like I mentioned, you have Docker desktop, everything is ready. Just go here and runs one single command. Nothing much. What is the command? Docker run, and I'm using -d to run it as it's called detached mode, or like just running in the background, like many of you are using Docker might have it. And then I'm also mentioning the port. So the local port 80890. I just wanted, I'm just changing this port because I don't want it to get it conflict with any other port. But you can, you can also make changes 8090 or like some port. And then I'm using, so it has two containers. One container is using port 8090 and another container is using 1935, right? And then what it is running, it's running a OwnCast server. OwnCast is a streaming server, and it is trying to run that. Okay, I'll just run this. So it's telling like the OwnCast image is not in local, it is trying to pull it, right? So it is trying to pull. It may take a minute or two, and then once it is done, I'm telling the story, right? Like my Docker learning stuff. So I started just understanding Docker, and then I gone through some of the tutorials, and I ran couple of commands just like this: Docker build, Docker run, and Docker ps. And I thought like, okay, that's it, Docker, right? And then so now you see, I just ran this thing, and it is running on 8090 and like 1935, right? Like, so I'll just try to open it and I'll show you what it has, right? So I'll just say localhost colon 8090. So it has new OwnCast server. Nothing is streaming it. Yeah, but it has some like it is nothing is streaming, but it is configured. Now if you just go here and / do admin, okay, just 1 second, maybe it is internally using the same port, that is the reason. Yeah, just one more time. I'll just keep the same container, same command I'm trying to pass it. Okay, now instead of 8090, it should run on 8080, which is running fine. So I'll just try to this is the OwnCast server, and then the same thing, it has some admin config as well, so that also I mentioned in the document. So the default username is what, admin abc123. Admin is the username, abc123 is the password. So here we have this that OwnCast server settings, right? So now like what we are trying to do is like we are setting up a streaming server. It's just like with one command, and we have the server background ready, and then here like in the configuration also like we have a number of things. But to stream it, like how we are streaming our event, like OBS Studio, you need to have it installed. So for just now, for this, like just monitor it, like you don't need to run it. So here, I just have the same configuration. So if I just go settings and stream, okay, what I did is like whatever the port which is running on localhost 1935, right? Like which we run just container now, right? 1935. This configuration is the stream configuration for the RTMP. I just provided that. Nothing much. The same password ABC123, and then I just specified this URL. Clear so far? So now, what I'll do, I'll just start streaming. Okay, and I'll go back here. I'll just try to refresh. Okay, whatever we are seeing there, or like whatever we are demonstrating, we are just live streaming our workshop. So it will be on the loop mode. Okay, and for the first time, like when I saw this something like this using couple of commands with Docker, I thought like, okay, I became an expert in Docker, right? Which is possible because like every time we just look around and like there are some commonly used commands and nothing was that I'm doing. I thought like, okay, that is Docker. But this is very top level view. So how you ran a simple with a single command, how you stream or like any sort of application which somebody built it, configured, that is not something you're gonna see every time, right? So what generally have, a lot of these scenarios are like what we are seeing today, which I came across, which in my 6+ years of working as a DevOps engineer, and then I tried to put this in the matter. Now, what I'll show you is, I'll just show you one scenario, which is networking. So here, what will happen, I'll just go through the code, a simple application we have, or yeah, I'm just bringing that application. Okay. It is trying to pull that image, PyCon 3.1 and everything. You can also follow along. You can just run this. Okay. So I have this simple porting application between to work from home or work from office. Okay. And yeah, what essentially has to happen, everybody is on the same page. Like in Docker, we are just trying to run the scenario 3. Okay. I'll just let it complete. I'll just rerun again so that it will be more clear. So simple. We have simple voting application. If I vote either of these, it should work, right? Okay, I'm just running. So I'm just trying to refresh. So container didn't came up. I'll wait for the container. Yeah, if you see. So if you see, it says voting failed because it couldn't connect to the Redis database. So the similar example which we saw earlier, we have two containers. One is application container and database container. That Redis database couldn't connect, and then that's where when I click on vote, it is not happening. So what it did is, I gave a pause here, right? So to keep everything in the same container. And now if I just wait for some time till the other container come up, I'll see the voting is happening. Right? So it looks so simple, but this is a common pitfall. What will happen? You create different images. You run them, like you run as a containers. When you run any image, it will become container, right? So those containers, if they are not in the same network and if they are not talking to each other, then you will see this issue which you got earlier. But as and when you establish this connection between two containers, that's where you see the working application. Getting it? Any queries? So after some time, like it get trashed out. So I kept a 30 seconds delay to just explore, and then after 30 seconds it will get terminated. Any questions? Anything? So that is one scenario where you have different containers, but if they are not in the same network, you tend to miss this, right? And similarly, I'll just go through one other scenario, which is multi-stage. So multi-stage container is again a simple application which I'll show you. So when we run this, right? So I'm just running this simple command. I'm just running the intact to PyCon file, and it is trying to pull the images. Okay, meanwhile, so in the scenario for in the multi-stage, I have like two Docker files. You can see this, right? So this is a bloated Docker file and another is a optimized Docker file. So what we're trying to learn here, if we just use the base images without any specific images, and then you try to install many packages in this way, right? You tend to have the image have like in a larger size. So that is what it is taking more time. So what it is doing is, so I do one thing. So I'll just go to diff compare, diff checker. So what I prepared is, one is this bloated Docker file, which generally people tend to use, and this is the optimized Docker file. Okay, if you just see the difference. So initial thing itself, right? Like now here I just initially put Python 3.10 directly, and here I am introducing as a multi-stage one. So multi-stage building is something when you wanted to build your application in stages, instead of like reusing everything and then building n number of times unnecessarily. What you can do, you can specify stages, stage 1, stage 2, stage 3, and then in that stage, what are the things that you wanted to run, you can just run only that particular portion. That is how your image size will be less, and then it will be optimized. So that's where we decided as a like builder is one stage instead of just pulling complete thing. So we ran it as an image, and here also like what are the things that you wanted to run it, like so apt install y all those things, right? So instead of just throwing into same way, like we just bundle it as a essential package, right? And then you also specify the environment, that hey, I don't want like everything to be created at the root level. Just like the first thing we created test containers virtual environment and we ran through those things, right? Similarly, I am trying to follow the same approach, and then now within the custom image or the specific stage, and then what are the files or packages that are needed, and just installing only those. So, and that is like stage by stage, like wherever I need, whatever I need, I'm just trying to run the same instead of just keeping everything as an open. And what is the difference? Like it is still building. So you'll see the like difference, like when you use normal image, just randomly pulling it from the Docker Hub, and then if you use specific tags that are like in our case, like if you use slim image or whatever, how it will be helpful and how difference it makes, that we're gonna see. Okay. It's taking a lot of time. Is there anyone else ran this? For you it is up and running? Anyone? If you see like all the packages which are like even though not needed, everything try to put it and it is trying to install everything. Just give it a minute or two, and if not, we'll go to another scenario. Meanwhile, any questions or any doubts so far? I'll try to run another scenario, maybe, because it is taking a lot of time. We'll see any other image. So actually this is what I wanted to show, like when you use this kind of images, like it unnecessarily pick all the packages and it eventually leads to something which is unnecessary and like taking a lot of time. But if you use like a expand like optimized files, it will be very short and then at the point, and you don't feel like taking a lot of time. Okay. I'll interrupt this because it is taking a lot of time. I'll try to show another scenario, or I'll run in another terminal maybe. You're getting it, like so for everything, like there will be two ways. One is the good way, and then one is the like random way, which eventually tend to fail. So that's what like we're trying to the regular way which we do is like we're trying to put it in chaos, and then we're trying to fix it on the another way. So I'll just try to run this scenario file. at least if it come up. It is trying to run a bit fast compared to other one. This is the sixth step itself. Sorry for the internet connection because like we tested and all those things, like it's fast, but due to internet connection it is like taking more time. Sorry for that. Yeah, this talk is so everyone is in the same network. Is this Wi-Fi or like is anybody having different network and like for you it is working quick? Anybody ran previous scenarios or like have any issues like meanwhile? Maybe I can help it like if you are running or if you are getting some sort of issues while it come up. Focus. I'll just wait for a couple more minutes, not just into the Jenkins. Sorry, what is the use case?
Having two stage, builders,
Yeah. Now this is something. Now you have like multi-stage, right? Like multi-stage is nothing but like for example, your production is like your infrastructure, the application deployment hub. For example, say 3 environments. One is development, one is testing, and then production. Right? 3 environments. So now you have the same application. Same application, you wanted to build it to 3 environments. First you build for development, and then you build for testing, and then the same thing you promote to production. That is the standard scenario, right? Now in this, from dev to testing, your code base won't change. What will change is some of the configuration variables. Like your dev server URL might be same, or your dev server, like for the credentials. For the dev, you might have like some username, password, or some tokens and everything, right? And testing you might have different, and then production you might have completely different. Except that your core code, which is running your application, remains same. Imagine for every environment you wanted to build the same application, then you need to, for example, if it is taking 1 CD for the whole application to handle, 3 times you need to build it, it's like 3 times the cost. But if you build one code once and just pass the variables separately, which are like stage level variables. In stage 1, which is dev stage, I have a username dev1 and password, and then testing, test user, and then test password, production user and password. So your code, the artifacts which essentially your images, everything, you're building only once, and then you're explicitly passing these variables separately. So that's where if you have 3 environments, your size will, the time and efforts to run everything will be 3 times lesser. And if you have 5 environments, instead of like taking as 5 times building 5 times, you build it 1 time, pass variables 5 times. So that's why you have multi-stage. And yeah, similarly, like all other scenarios also, like we have like 2 variants, like we discussed, like so there is one in the security also, like we have 2 different files. So like will it come up, I don't know, it's taking too much time. I'll try to explain like what are the differences between the secure Docker file and vulnerable Docker file, right? So in the secure Docker file, which means you don't pass the passwords and things directly. And if you just look at this vulnerable directory, sorry, vulnerable Docker file. You can see my screen, right? So all these things are fine. It has a standard image and all those things. But if you look back and observe closely, so here we have directly passed these environment variables and their values as here, right? That's what I wanted to show. Yeah, I think it is coming up. So what we have done is, like, yeah, I just ran this application which is running on port 8000. So this is a vulnerable Docker app. I will just try to zoom in. So it has like a lot of security warnings. Why? It has like database password, everything which we are seeing here, right? So here. So your database password is kept here, and then your API key is also in the Docker file, and then JWT authentication token also there. Everything, whatever is crucial for the secret, which what we do generally, we try to pass these variables for the testing in the lower environments. and we tend to forget that and we commit the same thing to higher environments. And imagine the impact if some credentials got stolen from your code, which are exposed. And obviously there are a lot of code scanners which are available these days, and something like 3D, which do the sonar cube will do the code scanning, and 3D do the container scanning. All those things were there, but if you are a little not so serious and then by mistakenly pass some of these variables, it will create these kind of issues. So it listed all those things. And down, if you see the secure which is built using the secure Docker file. Okay. I think it ran and it will it is trying to build another container. What it has is whatever the issues which we are seeing, so we got fixes for that in the other file. So you can just keep them side by side and then see the secure Docker file. So if you just see this secure Docker file, so essentially same thing. Same thing, the multi-stage build and all those things I used it, but I didn't pass any variables here. I mean, for the variables I don't pass any values. Okay, you see, the environment is what we passed, but like secret keys, database passwords, all those things we didn't pass. So, but environment is something very basic, like you need to pass it, because if you don't specify which environment to build, you don't know like where to deploy it, like how to build all those things, right? Like the same thing which we talked about, the environment specific variables. If you don't specify environment here, it don't know like what variables to use. So yeah, only those things we have used, and then we didn't use any security key, database password and other stuff. So ideally when it should come, so it is like kind of linked to that, and then like here we need to have a secure Docker application, and then the comparison why it is good, why it is bad and all. Okay, that's about like some of the standard practices that you always need to remember, like when you're building an image, like what image you are taking, and then how the first scenario, or which we saw, the second one is the networking one, whether my containers are talking to each other, they are in the same network, and then only like the whole application should work. So all these things we should be cautious when you're writing a Docker file anytime. Especially if it is going to production, you need to be a little more cautious. Any questions on Docker part? Yes, no? Okay. Yeah, it's taking a lot of time, but yeah, what I do is like just keep it. I just try to clean this up using PyCon clean.py file, and then I'll just remove this, and then we'll jump on to Jenkins. How many of you have experience in Jenkins? One. Okay. Yeah, let's touch base upon that. What is Jenkins? Right now, imagine you have containers, and like you have the code, right? You have the code which is built by your developers, and then you are kind of you're kind of building it like you have the code ready and you're building Docker images using Docker or like any containerized tool. You're packing it and you're calling it as uh, like my Docker image, and you're running it as a container, and that essentially that package you're trying to run it. But what will happen when you wanted to do it everything manually, right? Just like how we did so far, like we went on and manually did everything by own, running by file. So this is kind of difficult, right? Like when you wanted to have the same kind of thing in production environments or any other environments. So you need to automate all this testing and build process. So Jenkins is a tool which will allow us to automate all this building and testing process, right? So remember that, and then with that we try to get into Jenkins. So again, the same approach, not new. So we have like various scenarios and then stuff. Well, first go to Jenkins. Okay, I'm in Docker scenarios. Okay, yeah, I'm in the Jenkins. So for in the Jenkins, I have one single script, which is Jenkins setup. I'll see how much time it will take. Jenkins setup, and then I need to pass the parameter. So once you are running this, and then later if you want to clean up, the same command instead of setup, if you do a cleanup, it will clean up. Okay, so it is again taking some time. Okay, it failed. Nice. Okay, no container is a Jenkins workshop. Okay, trying to issue. So earlier, okay. One second. Okay, so it has some dependency. Just let me discuss. Okay, Okay, for the interest of time, I'll just run another Kubernetes stuff. So instead of like studying into that. So like for all those things, we have the same thing, like scenarios and everything. So first one, what I'm going to do is like I have a simple Python application. Okay, and it has the K8s and like the similar stuff. So once you have the Docker desktop, and then you can enable Kubernetes from here. Okay, I have enabled my Kubernetes cluster from the Docker desktop. So now, if I just run Python 3, and then in the K8s, this is the file name. K8s. So I'm just trying to run this. So this is like again which we similar to we saw in the previous scenarios, right? So this is the intentionally will have like lot of failures and stuff. So once you run this, so it has many issues. These are like in Kubernetes, everything you write is an YAML, and then this YAML is the main thing that shows like what is the configuration, how everything is mapped and all. And then so main thing is namespaces. So here it is telling it is missing the namespace, and then some secrets related mapping, everything is failing. So that's why like when you run also like you run into these kind of issues is what it is trying to tell. Okay, now what is the solution, right? Now similar to this chaos, we have the solutions. And it has a deployment file. So whatever we saw the issues in the earlier, so it should fix all those things. Okay. Once you run this, and there are like some standard Kubernetes commands, just like kubectl get ns. To just see what are the namespaces, and the latest one is like voting app. This is the namespace. What we are trying to do is like we wanted to see what are there in the namespace voting app. Okay, it has all these services and other stuff, right? But what service we are interested in is the voting app service. So what I am trying to do is I am trying to it is running within a cluster, right? I am just exposing it to the port forward. So now it is running on the port localhost 31004. So if I just go back, (31004). So same application which we saw earlier. So just like record words and the stuff, but the learning from here is, so if you are not so careful about like what variables which you are passing and all those stuff, right? Example here. Again, I'll just show you both in comparison. So like what went wrong initially, and what we kind of fix it, right? So if you just find the difference, so initially there is no namespace at all. Namespace is the logical segregation, right, between resources. So you don't have that. Like now you have the you don't have the right mapping there. So you did that mapping, and then replicas, like initially it was just scheduled to 1. And if something is broken, your application will go down. So for the high availability, we have increased the number of replicas. And then in the environment also, like if you just pass environment variables and all, like there will be a lot of dependency with the pods and all. That's why you remove all those things. in addition to that, you added the request and resource, like this pod has to, how much memory the pod has to take, all those things, and then you also had a health check and other stuff, right? So all these are the things which are missing and initially when you have the issue, and once you run this, these are the things which we got fixed and then it started working. So and to just conclude, so everything what we see now is like kind of interlinked. So it's a complete journey between like one place to another place, like how you write your test cases, how you containerize your application, and how you deploy in your pipeline, and then essentially how you release this application to end users. So if they work together, you'll have a good time, and you'll have a good as soon as like they are working together, you'll have a good time. And there are multiple things that are bringing together, like starting from Git to building the pipelines and everything, right? Like what we talked about. These are the connecting dots. So if everything is fine, you get these kind of benefits, that you have a good vacation and better sleep, and then for the customers you'll have a better delivery, and then you'll have like happy end users. And that is just one more thing, like go and build pipelines that world can trust. So that's what leads to setting up reliable pipelines. It's not just building something and then just delivering it, right? Like you need to consider all these are like very small things, but like if you just kind of miss the track of one thing, it will lead to a lot of eruptions, right? So that's what is learning. And once again, I just wanted to say sorry about this internet connectivity and like images thing. A lot of time we just couldn't pull the images and run our stuff. But with whatever the stuff, this is what I have. And I'm Koti Vellanki once again. And thank you so much.